Okay, well, it's 10 o'clock, so we can go ahead and get started. Thank you all for joining us for another edition of the Long Coffee Break. My name is Bill Roan, and I'm a senior sales engineer for Long. And today we are going to be talking about noise control solutions for different HVAC applications. We are lucky enough today to be joined by Vivek Chowdhury with Vibro-Acoustics. Thanks, Vivek. With that, I'll hand it over to you.
Thanks, Bill. Hey, good morning, everyone. Thanks for joining in today for your coffee session. My name is Vivek Chowdhury. I'm from Vibro-Acoustics. I'm the regional manager at Vibro-Acoustics, been there with the company for 7+ years. I started as an application engineer and moved into this regional manager role in the last 3 years. Today, we're going to talk about the noise control for different HVAC equipments and how noise is critical for different applications as well. So for introduction, which projects needs to consider noise control? Basically, people think of performing arts, radio, TV studios, libraries, and churches, but there are all different other applications and projects like healthcare facilities, educational facilities, lab science, pharmaceutical application, data centers, or any residential building, or actually any building that needs to meet a city bylaw code for noise as per the city requirements. For Vibro-Acoustics and Long buildings noise control, the way we look at it is a big picture view. If you can see on the slide right now, we are showing all different HVAC equipment that can be a part of a building in terms of rooftop units, air handling units, chillers, cooling towers as bigger equipments. And then at the same time, like VAV boxes, dampers, and diffuser. So whenever Long buildings and Vibro-Acoustics look into the project, we see where are all these HVAC equipments located, how much sound they are creating, and how is the ductwork coming from these units into the occupied space. So why do noise control problem exist? Basically, it can be someone think of noise control and design something from a consultant point of view, but then it was VE'd out or value engineered out. But is it actually worth it? Because the noise control solution is actually less than 1% of the mechanical budget of the total cost of the project. But in case is there any issue down the road after they are VE out, it's gonna cause 5 to 10 times more because we have to do all the ductwork apart, put the noise control solution in, and redo the whole ductwork again. So let's talk about some common problems now. The first one I have is pressure drop. So I would like to differentiate between idle pressure drop, as we see in when we are doing some lab testing here in our Toronto plant, compared to a system effect pressure drop. So when I say idle pressure drop or lab condition pressure drop, we follow this ASTM E477 testing requirements, which says you need to leave 5 of straight duct at the silencer inlet and 10 diameters of straight duct at the silencer outlet. So we are talking about, if we have a 5-foot straight silencer, we are talking about 15 to 20 feet of straight duct. How many times we have that much of a space in any building? Almost none, right? So we need to consider this, these are ideal conditions. We need to consider what are the real system effect conditions after that silencer is installed to calculate the system effect pressure drop. Let's take this as an example. So the straight duct silencer is installed right after this elbow, and then there is a straight duct after the elbow. If we have considered and put this straight silencer from a catalog point of view, or an ideal pressure drop will be 0.15 inches at 1,000 feet per minute velocity. But once we put that after this elbow and we calculate system effect pressure drop, which is based on the real inlet, which is an elbow, and real outlet condition, pressure drop is actually 0.78 inches at the same velocity. So again, this is not a right solution in this particular case. The right solution will be an elbow silencer, which will act as a duct, and an elbow silencer as well. So it will start from here and it will be an elbow all the way there. So basically it will have a better performance and a better pressure drop as well. So we need to consider what are the right solution for different application at the same time. This is how Long buildings and Vibro-Acoustics, when we work with you guys on any project, this is how we show it. We always show 2 pressure drop. One is idle pressure drop and second is a system effect pressure drop. This is the maximum pressure drop of once these silencers are installed, it will not cross this pressure drop. So there will be no surprises to the contractor and the building owner after these are installed. We also put some notes here, which any consultant looking into the project can review it. Basically, we are providing all the calcs needed for that project to provide you the background on the job, what Vibro-Acoustics and Long have done. And also we provide PE stamp pressure drop calculations as well. The last note here says silencer must have a HTL casing to control the breakout noise issue. That actually comes to the common problem number 2, which is breakout noise. So let's take this as an example. If we have this air handling unit located right here, and noise is actually coming through this air handling unit into the occupied space. So somebody looked at it and put these 3-state silencer, the yellow boxes you're seeing here are 3-state silencer to control the breakout noise issue, because they are putting basically a silencer in every single duct. Do you think there will be a noise issue? Yes. And what will that be? Because breakout, basically to define breakout is the noise which is actually breaking out of the duct itself and going into the occupied space. So this space right here will have a noise issue because there is nothing here to prevent the noise coming from the air handling unit. What is the right solution? A T-shaped silencer, which will take care of not only the airborne noise, but also a duct-borne noise with a better performance and a better pressure drop at the same time. To deal with the breakout, we need to look into what is the space affected for that breakout noise issue. And a calculation is always needed, which anybody from Vibro-Acoustics team and Long Building team will be happy to help you guys to calculate, is there a breakout issue? If there is a breakout issue, then we calculate how much it is. And then we provide a HTL casing silencer. Basically, HTL is a high transmission loss casing. It's a thicker gauge casing of the silencer to make sure noise is not going out from the silencer itself. Let's talk about the integrated system approach. So integrated system approach is a combination of acoustic analysis and a system analysis. So whenever anybody is looking into a project to make sure on the noise, especially the acoustical consultants, they focus on the acoustic sides of any project, which is how much noise control is needed, is there a breakout noise issue, and what are the different noise paths. And from a mechanical consultant point of view, we look into the maximum pressure drop allowed, the system effect, and how much room is there to work with. So basically what Vibro-Acoustics and Long Building will do is making a combination of both. So we provide a solution which not only works on the acoustics point of view, but also works from a system point of view as well, to make sure the solution will fit in the space and will not exceed the maximum pressure drop allowed. Now I have some application specific solution. The first one I have is a rooftop unit equipment. So right here in the yellow highlighted is the sound power data of the rooftop unit in 8 octave bands. Ideally, where do you locate a rooftop unit? I see most of the time a rooftop unit is located on a non-sensitive area in terms of noise, like a corridor, a washroom, a lobby area. But then at the same time, I have seen sometimes the rooftop units are located right above the occupied space, like a meeting room. In case you guys have different rooftop units, 1 or 2 will go on top of a meeting room. So this is a solution when a rooftop unit is located right above the occupied space, which is a noise sensitive area. There are some benefits of that as well if we do that. The first benefit is it will be energy efficient design, lower building costs, space saving design, and time saving design as well. But the problem will be noise problems and client complaints. So if we have a rooftop unit like this, located right above this meeting room, there can be 14 different noise paths noise can travel through from the rooftop unit into the occupied space. So what we do the analysis and then come up with a solution similar to this. We call it integrated noise control package, which is a combination of vibration isolation curve, acoustical barrier, and supply and return silencers. So it's a package combination of few noise control solution to make sure we are meeting the required NC criteria right below the space. And we provide all the different calculation to support this, like pressure drop calculation, noise control calculations. If it's needed to be wind load or seismic rated, we do that as well. And these are some pictures of the solution after they are installed. If you see from outside, it looks like any other standard vibration isolation curve. And this is how we will provide it to you in Excel format for your review. Once we work on that, it will show a unit tag number, equipment type, the height of the curve, supply pressure drop, return pressure drop, and what are the NC criteria. For example, rooftop unit 1 is designed for NC 30 and rooftop 9 is designed for NC 25. And these are all the notes for your review as well. Let's talk about some generator application. They are pretty complicated in terms of, because they need high noise reduction and there are tight spaces for generator application. One example here is a Memorial Hermann Hospital, which has 6 2.5 megawatt generator. And the property line requirement is 55 dBA at 90 feet away of the property line. So we actually look into it. After our analysis, we come up with some big discharge and intake silencer banks like this. We also have done a testing in our R&D lab here in Toronto before we ship it to them. And then we provided the phase 2 and phase 3 of this application as well. So basically, Vibro-Acoustics and long buildings can work on different applications for different equipments. These are just 2 examples I showed you in terms of rooftop equipment solution and generator application, but we can also work into cooling towers, chillers, any equipment which is making a noise for different application like hospitals, schools. All you need is to send long buildings the mechanical drawings and the sound power data of the equipment, and we'll be happy to help you. The next slide, I will give it to you, Bill.
Thanks, Vivek. I really appreciate it. Thank you all for joining us on this coffee break. Please reach out to your long sales engineer for additional information on Vibro-Acoustics noise control solutions. Thank you all again for joining us. Have a great day.